is what? Is a quadratic polynomial represent a parabolic graph. You can see this is a parabolic graph, could be upward or could be downward like that. Now, before reading the option, what we can do, we can write our standard formula, and that is what? A times x square plus b times x plus c is what the representation where a should not be 0, right? A should not be 0. Because you see, if I make this a as 0, this whole thing will vanish. At the end, we are getting a linear polynomial. So this is what the correct. Now, if I see the option, well, this is correct. Why this is not correct? Here they are writing C is not equal to 0. We should write A should not be 0. And here they are writing B is not 0, right? As I said, A should not be 0. But then why it is not? Even this is true. Even this is true. As you see, if I write a polynomial 7, say 5x square, 5x square minus 7, right? Simply 7 constant. This will also represent a similar kind of polynomial. So there are two correct options. Maybe if there is some printing error on the question, but we can say in such a situation, both are correct. One should get marks for this as well as for this option. Both of them representing a parabolic graph. The next question, that is second part, it says Kavita draws a parabola passing through these points. These are the points, right? Let's understand these are the points represented and they are not the zeros, right? And what we have to find? Yeah, we have to find the zeros of this polynomial. Well, let's understand once again. What are the zeros of the polynomial? Through the graph, it is the x coordinate of the point where the graph intersects the x-axis. Like over here, if I ask you what is the x coordinate, you should say -2, 0, right? I mean, x coordinate is -2, and the coordinate is -2, 0. And what is this? 4, 0. Now take the reference of this. What you can see that the graph will intersect the x axis when its y coordinate is 0. You check here the y coordinate, as you can see, the y coordinate is 0 over here and y coordinate is 0. So first of all, you have to look for those points where the y coordinate is 0. Let's see here, this is y coordinate is not 0, so discard it. Y coordinate is not 0. Y coordinate is not 0. Y coordinate is not 0. Only these 2 points has its y coordinate as 0, right? So therefore these are the coordinate of the coordinates of the graph which touches the x-axis, and its x coordinate are the zeros of the polynomial. So what is its x coordinate? -1, and here is -3, right? -1 and -3 are the x coordinate of the point where the graph touches the x-axis. So now we can declare -1, -3 are the zeros of the polynomial. I can see C is the correct option in this case. In the third part, it says which of the following is correct. The first option is a parabola intersect x-axis at maximum 2 points. Well, before we read the options, let's understand we are talking about a parabola. Everywhere it is parabola. You can see all options have parabola. That means here we are talking about a quadratic polynomial, right? We are talking about a quadratic polynomial. And if I ask you what are the zeros of a quadratic polynomial, you may say, you should know that the zeros of a quadratic polynomial, right? Quadratic polynomial can have at most 2 zeros, right? That means it can have no zeros, can have only 1 zeros, and can have 2 zeros, right? These are all, right? It can have either no zeros, no, it's not 0, it's no 0, right? It can have no zeros, can have 1 0, can have at the most 2 zeros. Now, if we read the options, we'll be able to figure out. I think we will read from, okay, let's begin with the first. The first one is a parabola intersect x-axis at maximum 2 points. Yeah, that is true. Now, if I read other options, a parabola intersect x-axis at only one point, right? Not, then we say this is not correct because it can intersect at 2 point also. Now, a parabola intersect x-axis at exactly 2 points, not necessarily be, because it can intersect the x-axis at 1 point also. Like this is also a parabola. You see, this in this case it is touching the x-axis at 1 point. The last one, this is a parabola intersect x-axis at least 2 points. Well, some student get confused. At least two means minimum two, right? At least two means 2 points means minimum 2 points. So they mean to say that two or more than 2 points, right? They mean to say two or more than 2 points, which is definitely not correct, right? The correct is can be at most two and not at least, right? At most two and not at least. So therefore, this is also not correct. So clearly, this is correct because they are saying that maximum 2 points. By that, they mean to say that 1 point, 0 point, or 2 points. In the fourth part, it says the product of the roots of the polynomial this. Right? We are given this polynomial and we have to find the product of their roots. Now, first thing that we do is to write this polynomial in the standard form. It's very simple, just opening the bracket. So 5x multiplied by x is what? This is 5x squared. And 5x multiplied by negative 6 is what? Minus 30x. Am I right? Yeah. 5 into 6 is 30. Now, if I write the polynomial in the standard form, and what is the standard form? This is ax squared plus b times x plus c. Now, comparing these two, what I can say, a is 5, right? A is 5 over here, and b is what? B is negative 30, and c is 0. As you can see, there is no c, so c is 0. Now, what we have to find out is the product of the zeros. We have to find the product of the roots. Well, roots and zeros are same over here. Not in case of a polynomial, we consider same. In fact, they are same. Interchangeable word. Now we are coming to the product of the zeros is what? Product of the zeros is equal to c by a, the constant term divided by coefficient of x. So now what is c here? C is 0. So 0 divided by a, and what is a? A is 5. So that results to give you what? 0. Yes, we have an option, and that is D is the correct option in this case. In the fifth part, this is sum of the zeros of a quadratic polynomial. Well, this is what a quadratic polynomial given. In the standard form, we are asked to find the sum of the zeros. Well, sum of the zeros, that is alpha plus beta, is what? Minus b over a. That means negative coefficient of x divided by positive coefficient of square term. Well, they haven't changed anything, right? This is what the standard. Sometimes they change it like this, right? B times x square plus a times x plus c, like that. In that case, this is our negative coefficient of x. But anyway, this is a very standard form. So we have a option here, that is minus b by a. That is option C is correct in this case. In the next case study, it says Sweta and her husband Sunil, who is an architect by profession, visited France. They went to Mont Blanc Tunnel, which is a highway tunnel between France and Italy. Under Mont Blanc mountain in the Alps, has a parabolic cross section. As you can see, this is a parabolic cross sections, right? The mathematical representation of the tunnel is shown over here. So based on this, we have to answer the questions. Now let's say so the first part of this first question is the zeros of the polynomial whose graph is given are. So we can see there is a graph given over here, and we have to find the zeros of this polynomial. So what are zeros? It is the x coordinate. It is the x coordinate, right? One more time. It is the x coordinate of the point where the graph touches the x-axis. So you can see that where is the graph touching the x-axis? One at this, another is this. And what is the x coordinate of this point? This is -2 and 8. So we'll say that -2 and 8. Option A is correct in this case. In the second part, it says what will be the expression of the polynomial given in the diagram? Well, we have first found the zeros. What were the zeros? The zeros were -2 and the other 0. I'm using alpha and beta to write their zeros or represent the zeros as 8. Now we have to frame the polynomial. And what is the formula for writing the polynomial? It is k times x squared minus sum of the zeros times x plus product of the zeros. Now keeping k outside, this is x squared minus, what is the sum of these two? It's 6. So that is 6 times x plus, well, this minus sign is for the formula, plus the product of the zeros. And what is the product of these two? It's -16. Right. So k will vanish and we can say that this is what? The polynomial. So I can see we have an option. Let's check. Yeah, look into this. When you try comparing these answers, you say that x squared minus 6x minus 16. Well, there is not, this is not, right? Then it is not to this and this also. So in such a case, what you need to do is to take out minus common, right? So as I said, k can take any value. So I can write minus over here. And this will become what? Minus x squared, as I'm taking out minus common from here. So minus x squared, this will become positive 6x. And this will also become positive 16. Now you can compare. You can compare from here that this match with which of them? Yes, it is B part is correct in this case. Now in the third part, it says, what is the value of the polynomial represented by the graph when x is equal to 4, right? So we are not going to use the graph, right? At x is equal to 4, right? Y can have some values. Now that's what we have to find out. For that, we are going to use the previous answer. So we got the polynomial. Well, this was the polynomial represented by this graph. So now we have to find at x is equal to 4, the value of this polynomial. So it's very simple. We are simply going to replace x in this polynomial by 4. So it's going to be what? Let's say if I write this polynomial as, say, this is px, right? If I write this polynomial as px, so this px is replaced by 4, right? So I'm going to write 4. Let me first write down the polynomial in order to avoid any confusion that you might be having. So what I'll write, I'm writing the polynomial, which is px as minus x squared plus 6 times x plus 16. Now check, if I replace x with 4, is going to be what? Well, this is outside, right? Minus is outside. And replacing x with 4. So wherever there is x, I'm writing 4 here, right? Plus 16. So this is what? Negative 16. This is 24 and positive 16. So this get cancelled over here. You can see this getting cancelled. So we are getting 24, right? We are getting 24. So we have an option, that is option C is correct in this case. In the fourth part, it says if the tunnel is represented by, we are given this polynomial, right? Including minus sign. Then the zeros of this. So clearly we have to find the zeros of this polynomial, that is minus x squared plus 3x minus 2. Either you can do directly, or if you are having problem, you can take minus common to write to make this as positive. Minus 3x plus 2. So what I did, I simply took minus as common. Now I'm finding the zeros of this polynomial by prime factorization method. So from the factors of 2, I have to obtain minus 3. So it's going to be what? Minus x minus 2x, right? Plus 2. So what I actually did here, I replaced minus 3x with minus x minus 2x. Now what next? I'll take common from the first two term. We have x as common. So it becomes x minus 1. And from the last two term, it's minus or negative 2 is common. So that is x minus 1 again. From the whole, I can see x minus 1 is common. So it is x minus 1 into x minus 2. Right. So now from here, what you can see that equating this with 0, I'll get x as 1. And equating this with 0, I'll get x as 2. So positive 1 and positive 2 are the zeros of this polynomial. So in the fifth part, it says if 1 0 is 4 and sum of the zeros is minus 3, that means we are given say 1 0. I take first 0 as alpha and alpha is given as 4. And the sum of the zeros, if alpha and beta are the zeros, their sum is given as minus 3 or negative 3. Now what we have to do is to representation of this polynomial. So we are going to represent it. So what we know that how do we frame a polynomial? It is k times, well, k is any real values, k times x square minus sum of the 0 times x plus product of the zeros. Now, if I replace this alpha, you see, we have this sum of the zeros, we have the sum of the zeros, but then we have to find the product. For that, what we are going to do is to replace this alpha. We know the value of alpha here, so we can replace this alpha with 4. So it's going to be what? 4 plus beta equals minus 3. So beta comes out to be negative 7. Now once we have the beta as well as alpha, we can find the product, right? The product is what? Alpha into beta, that is product of these two, comes out to be minus 28. Now you can see here, now here onwards we have the sum as well as product. So we now know the sum of the zeros and the product of the zeros. So this is what the sum of the zeros and this is the product of the zeros. Now this is k times x square minus, and what is the sum of the zeros? Minus 3. So this is negative 3 times x plus product is how much? Negative 28. So I'll be writing minus 28. Now if I open this bracket, right, opening this bracket, what we finally get, this is k bracket x square plus 3 times x minus 28. That's right. Okay, now when I compare this answer, do we have this option? I can see that as of now, this is not, this is also not, this is also not. Well, in this case, what I told you that in such a case, we take minus as common. So if I take minus as common from here, k, as I said, k can take any values. So if I replace k with minus 1, taking out minus common from here is going to be minus x squared. This will become negative 3x and this will become positive 28. Now check if I compare, I think, yeah, this one is correct. So the correct answer is option B in this case. In the next case study question, it says quadratic polynomial can be used to model the shape of many architectural structures in the world. Pursuing the field of Jersey City in US, one of such structure is given over here. As you can see, this is a structure given over here. Based on this, we have to answer the question followed. So now in the first part, it says if the arch is represented by this quadratic polynomial, well, clearly this is the arch over here, and this arch is represented by this polynomial. What we have to find out is are the zeros of this polynomial. So clearly we'll be using middle term factorization in this case. So let's say if I factorize this polynomial, the polynomial here is what? This is 10x square minus x minus 3. So now first thing we will do is to multiply, right? Multiply this 10 with this minus 3. So it comes out to be what? 30. From the factors of 30, I need what? Minus 1. So it can be 6 into 5 is 30. So we are going to split this. This is 10x square. I need minus x. That's why it's minus 6 plus 5x, as I told you from here, minus 3. Now I can see that from the first two term, what is common? 2x is common, right? So if I take 2x common, but I get 5x minus 3. And if I take 1 common here, we are going to get 5x minus 3 again. Now from these two, I can see 5x minus 3 is common. So 5x minus 3 when taken common, we get 2x plus 1. Equating this with 0, what we'll get? Should I show you? Let me show you. Equating 5x minus 3 with 0, we'll get x as what? 3 over 5. And similarly, equating 2x plus 1 with 0, what we are going to get x as? X as negative half. So now we can say that 3 by 5 and negative half are the zeros. Yeah, so this is what I can see. Negative half and 3 by 5 are the zeros. Now moving to the next part. In the second part, it says zeros of the polynomial are the points where the graph touches the x-axis, y-axis, sorry, not touches, intersect the x-axis, y-axis, intersect either of the axis or can't say. So if you remember, like if I make a Cartesian plane over here, and this we know that the horizontal one is x-axis, and if I make a parabola, let's say if I make a parabola like this. So how do we find the zeros? Zeros are what? The x coordinate. It is the x coordinate of the point where the line touches the x-axis, right? And not the y-axis. So we can say that the correct answer is option A in this case. Third part it says quadratic polynomial whose sum of the zeros is 0 and the product of the 0 is 1 is given by what? So if you see once again, we are given this sum as sum of the zeros as 0 and the product as 1. So if I write down the general formula for framing a quadratic polynomial, it is k bracket x square minus the sum of the zeros, right? The zeros are alpha and beta plus the product of the zeros, that is alpha into beta. Now check here, if I write sum is what? It's not alpha and beta, right? You should remember that we are given the sum of these zeros. So this is 0 times x plus product, which is 1 in this case. So what do we get here? This is, as you can see that here 0 times x is 0 only, x square plus 1, right? This is what we will get. Now one more thing, that k here is the any constant, and we can take k as 1 in this case. So we got the answer as what? X square plus 1 as the D part will be correct in this case. In the next part, it says which of the following has minus half and 2 as the zeros of the polynomial. Right, so we have to check which of these has minus half and 2 as the zeros of the polynomial. Well, you see, you have many ways by which you can check. Number one, you can find the zeros of each of them and decide. And the second way can be replacing x with minus half and 2. The one which satisfies these polynomial will be the zeros, but then they can take a longer time. Instead, what we can do here is simply to make a polynomial using these as the zeros and then compare the answer. So what should we do? We can write k times x square minus sum of the zeros. Zeros are what? Minus half plus 2 times x plus product of the zeros, that is 2 multiplied by minus half. So this is k times bracket x square minus, what is the sum of this? Has to be half minus 2 is 1.5 positive. So which is 3 by 2 times x plus here this get cancelled. So plus minus is minus. So we'll write minus 1. Now if I take LCM, it's going to be what? 2 times x square minus 3 times x minus 2. That divided by 2. Well, we can cancel these. And as I said, k can take any constant. So now we are left with 2x squared minus 3x minus 2. So we can now check it match which of them. It is D option, right? This is 2x squared minus 3x minus 2 is the correct option. That is option D. Now in this part, we have to find the product. That's the final part of this fifth part of this case studies. We have to find the product of the zeros of this polynomial. Well, product of the zeros we have to find out. So we are not going to find the zeros and find the product. Instead, we are going to use this relation that product of the zero is what? C over A. And what is C and A? As you know that if I write this polynomial, if a polynomial in the standard form, that's ax square plus b times x plus c. Now from here you can compare what is A. A is under root 3 and how much is C? C is 8 root 3, right? So this is what we are going to do here. So I can write from here that product of the 0, which is alpha beta, is C over A. And then what is C here? C is 8 root 3. And what is A? A is under root 3. So this get cancelled. As a result, we got product of the zeros as 8. So we'll say that option C is correct in this case. And the next case-based question, it says Priya visited a temple in Gwalior. On his way, he sees Agra Fort. The entrance gate of the fort has a shape of a quadratic polynomial. Well, this is what? The shape, and this is clearly a parabola, that is a downward parabola indicating it is a polynomial, that is quadratic. Further, he says the mathematical representation of the gate is shown in this figure over here. And based on this, we have 5 questions to answer based on this information. So let's begin with the first question. So if I type the first question over here, and what is it? The first question is this. It says find the zeros of the polynomial. What we have to do is to find the zeros of the polynomial represented by this graph. Now zeros are what? It is the x coordinate of the point where the line, or sorry, the graph touches the x-axis. One more time, this is what is our x-axis, right? This is our x-axis, and the x coordinate of this point, it is touching the x-axis at these 2 points, and the x-axis, x coordinate of this point is what? This is a bit blurred, but I can read it is 1 and 3, right? So we can say that the zeros of the polynomial is 1 and 3. One more time, it's important to understand that what are the zeros of a polynomial using graph. So it is the x coordinate of the point where the graph touches the x-axis. So the graph is touching the x-axis at these 2 points, and their respective x coordinate is 1 and 3. Now coming to the next question, question number 2, that is the second part. I can say second part of this question is what it says, what will be the expression of the polynomial represented by this graph? So for that we have to remember the standard formula for framing a polynomial. So it is x square minus the sum of the zeros, well alpha and beta generally we take as the zeros, multiplied by x plus the product of the zeros, as the zeros are alpha and beta, so product of the zeros will be alpha beta. Now what were the zeros? The zeros we have obtained as 1 and 3. So taking alpha as 1 and beta as 3. So if I write down the polynomial over here, it's going to be k times x square minus sum of the zeros, that is the sum of alpha and beta is how much? It is 4. So it is 4 times x plus the product of the zeros, and the product of 1 and 3 is what? 3. Well, k can be any constant over here. So we can see that this polynomial is x square minus 4x plus 3. So this is x square minus 4x plus 3. That's the option. This is option B only, right? Now, once we are done with this, let's come down to the next part. And the next part over here, if I type, what will be the value of the polynomial at x is equal to 4? Now, the polynomial over here is this, right? So if I write this polynomial, say as px, right, as x square minus 4x plus 3. So what we have to get? The value of the polynomial at x is equal to 4. So we are going to replace x with 4. So this becomes 4 square minus 4 into x. That means 4 times 4 plus 3. 4 square is 16. 4 into 4 is 16 plus 3. This get cancelled and we get this as 3. Right. So the correct answer in this case is what? Option C. Now coming to, we have done how many? Three parts, right? Now we'll have two more parts to do. So let's check what is the next part. That is the fourth part over here. Now for the fourth part, it says if one of the zeros of the polynomial is 7 and the product of the zeros is minus 35, then px is. Well, this part is not related with the previous, so what we can do, first of all, I'm writing one of the zeros. So since it is a quadratic polynomial, one of the zeros, let's say alpha as 7, and the product of the zeros is given as how much? Product of the zeros is minus 35. Now what if I replace alpha with 7? So 7 times beta is equal to minus 35. That results to give you beta as what? Minus 35 over 7. So beta comes out to be minus 5. Now check over here, we got alpha and beta. Now same way we can frame the polynomial, and the formula will be what? That is k times, if I write over, yeah, this enough space we can do here. So this is k times x square minus sum of the zeros, that is alpha plus beta times x plus product of the zeros. So this is k only. What you can see, this is x square minus sum of the zeros. So that is sum of these two. What is the alpha plus beta equals? It should be 7 plus minus 5. That is how much? As 2. So it is 2 times x plus the product of the zeros. So product is what? Alpha into beta, which we already know as minus 35. So plus minus is minus. So I can write minus directly. Yes. So we got this as the required polynomial, which is what? X square minus 2x. Now there is one thing you can observe, that it is not matching with this, right? Or this or this. So if you see that over here also this is not matching with the answers. But as I have taken k, and k can take any value. So if I take any constants, if I take out minus 1 common, right? So if I take out minus 1 common, it becomes x square. This will become positive 2x, right? And this will become negative. That is what I'm doing. I'm taking out minus common from here. So therefore the sign will get reversed. So that's why I wrote this as positive. This too will become positive. Now this, as I said, can take any real values as a constant. Now if you compare the answer, you will see that this is same as the first part. Now in the fifth part, it says that if the gate is represented by this polynomial, and the polynomial over here is this, right? What we have to do is to find the zeros of this polynomial. Right. So what we are going to do here is to simply factorize it to obtain the zeros. So what we can do, we are going to do use middle term factorization. What I can write 5x. From the factors of 6, I'm obtaining 5. So clearly 6 can be written as what? 2 multiplied by 3. So 3x plus 2x minus 6. If I take minus x common from here, let's understand again what I did over here. I simply split 5x as 2x plus 3x plus 2x. Now if I take minus x as common, what I'll get? X minus 3, as I've taken minus common. And from last two term, if I take 2 common, what I'll get? X minus 3 again. So finally we have minus x plus 2 and x minus 3. Now equating this with 0, we get minus x as minus 2, or you may say x is equal to 2. And equating this with 0, that is x minus 3 with 0, we are going to get x as 3. So it's positive 2 and positive 3. That is option B is correct in this case. In this video, we are going to do one case study question based on the chapter Polynomials. So question says that Shruti is a very good in painting. So she thought of exhibiting her painting in which she wants to display her latest painting in which is in the form of a graph of a polynomial as shown in this figure. Based on the above information, we have to answer these following question. So let's begin with the first question. It says the number of zeros of the polynomial represented by the graph. So make sure you are just looking for the number of zeros and not the zeros. So how do we get the number of zeros? So number of zeros, you can see that the number of times the graph touches the x-axis. So I can see it is 1 over here, second over here, and third over here. So what you should know, the number of times the graph touches the x-axis. So it is 1, 2, and 3. So we'll say it will have 3 zeros. Well, answer for this is 3, the first part. Now looking for the next part, it says sum of the zeros of the polynomial of this graph. So let's first find out the zeros. And what are the zeros? Zeros are the x coordinate, right? The x coordinate of the point at which the graph touches the x-axis. So I can see what are these? Minus 4, minus 2, and 1. So if I find their sum, it is minus 4 plus minus 2 and plus 1. So minus 6 plus 1 is what? Minus 5. So minus 5 is the answer. So one more time, we first found the zeros, and what are the zeros? Zeros are the x coordinate of the point where the graph touches the x-axis, and here the graph is touching the x-axis, right? And its x coordinate are minus 4, minus 2, and minus 1. But then we have to find the sum of the zeros and not the zeros, right? We have to find the sum of the zeros. So sum of these comes out to be minus 5. Now looking for the next question, it says find the value of the polynomial represented by the graph when x is equal to 0. So when x is equal to 0, you look into this graph over here. When you see that when x is equal to 0, this y, which is fx only, right? Y is fx, is 8, right? No, sorry, it's not 8. It's minus 8 over here, right? So we can say the answer for this part is what? Minus 8. Yeah, that's B is the correct answer in this case. Now coming to the last part. The question here is the number. Now, the polynomial representing the graph drawn in the painting by Shruti is what? Well, what you can see, it has how many zeros? It has 1, 2, 3. Now, it has three zeros, so it can be cubic, right? Cubic or even of higher degree. Well, as of now, from the graph, it is very clear that it has exactly 3 zeros, so it can it has 3 zeros, so we will say that it is cubic polynomial, right? So when a polynomial has 3 zeros, we say that it is cubic. But there can be a confusion. Uh, if the number of zeros over here is 3, right? So a cubic polynomial can have at the most 3 zeros and not exactly 3 zeros. But over here is the correct answer remains same, that is cubic polynomial. The next case study from the chapter polynomial, it says while playing badminton, Ronit seeing the barrier chains hung between two poles at the edge of the walkway of the street. Well, these are the chains. As you can see, these are the chains which are hung in the shape of a parabola, as we can see. Yeah, that's what it says, in the shape of a parabola. And the parabola is graphically represented for a particular polynomial. So parabola is what? Something like this. This is upward, this is downward parabola, upward facing and downward facing parabola. So that is parabola represents what? Quadratic, right? Quadratic polynomial. Now, based on this, we have to answer the question. So if I type the first question over here, so first question is what? This is what? Which of the following, the question over here is, which of the following polynomial is graphically represented by a parabola? So as I said, parabola that is can be upward or upward facing or downward facing is represented by quadratic polynomial. So quadratic polynomial is what? A polynomial having degree as 2. Now, if I type the next question here, the next question is this, that is, if a polynomial represented by a parabola intersect the x-axis at -3, 4, and it is intersecting the y-axis at -2, then the zeros, right? So what you can remember from the previous question, as I said, so if I draw a parabola if I draw a parabola something like this, right? So the zeros of the polynomial is the x coordinate of the point where it is touching the x-axis and not the y-axis, right? So we can say from here the zeros of the polynomial, you can see that it is touching the x-axis number 1 over here and number 2 over here, right? As you can see, it's -3 and 4. So one more time, the if you talk about the zeros of a polynomial, it is the x coordinate, of the point where it is touching the x-axis and not y-axis. So what you can see from here, that they are asking for the zeros of the polynomial. So clearly -3, 4, right? -3 and 4 are the zeros. Yeah, we have an option. This is option D is correct in this case. Now I'll come with the next question, and what is that? We have done 2 of them, right? Coming to the third part over here. In the third part, it says if the barrier chains between the two posts is represented by this polynomial, well, this is what the polynomial, then the zeros are. So how do we find the zeros? By first factorizing this. So I'm going to factorize this polynomial, which is x squared minus x minus 12. Now clearly we'll be going by middle term factorization. From the factors of 12, we need -1. So it should be minus 4x plus 3x minus 12. So what I did over here is middle term splitting. So I can split this. I can split this minus x can be written as minus 4x plus 3x. Now next is to take common between the first two terms, which is x. So it's x minus 4. And if I take 3 common, it's x minus 4 again. Taking x minus 4 common throughout, what do we get? X minus 4 and x plus 3. Now, in order to get the zeros of the polynomial, we'll be equating one by one with these factors with zeros. So equating x minus 4 with 0, we get x is equal to 4. And similarly, equating x plus 3 with 0, we get x is equal to minus 3. So therefore, 4 and minus 3 are the two zeros of the polynomial. Yes, it is option C. Option C is correct for this. Now we have done 3 of them. I have taken 5. Let's come to the fourth part. Now next is this one. All right. So if I see this question, it says the sum of the zeros of the polynomial, sum of the zeros of this polynomial is. Now, how do we find the sum of the zeros? Sum of the zeros can be calculated as negative coefficient of b divided by that I mean to, let's say if I write down the polynomial in the standard form, it is ax square plus bx plus c. Now comparing this polynomial with its standard form, what you can say that over here a is what? A is 4, b is negative 9, and how much is c? C is 2. Now we are required to find the sum of the zeros of a polynomial, taking alpha and beta as the zeros. Taking alpha and beta as the zeros, we have a relation between the sum of the zeros with that of the coefficients. So it is negative b over a. So if I replace, this is minus over here, the b itself is negative 9, so there will be another negative sign. That divided by a, and a is what? 4. So it comes out to be what? Minus into minus is plus. So it's 9 over 4. Yes, we have an option that is 9 over 4. That is B is the correct option in this case. So now we'll be doing the last part. So that is the fifth part. So what they say that the reciprocal of the product of the zeros of this polynomial, the reciprocal of the product of the zeros of the polynomial. So first we have to find the product of the zeros. One more time, we will be comparing this polynomial with the standard form, that is ax square plus bx plus c. So on comparing, what you can see that coefficient of x square is a. So that means a is equal to 1. B is what? The coefficient of x, which is minus 9 here, and c being the constant term. So c is how much? C is 20. Now, first of all, we have to find the reciprocal of the product. So first we need to find out the product, and how do we? So there is a difference, right? There is a difference when I say uh, we have to find the reciprocal of the product and not the product of the reciprocal. These are two different things. So first we'll be finding the product of the zeros, and then we'll reciprocate it. So that's the reason I'm finding the product of the zeros. And what is the relation between the product of the zeros and the coefficient? It is C by A. So from here we can see that the product of the zeros, C is what? 20 divided by A, which is 1. And what is the reciprocal of this? As you can see, I have to get the reciprocal of the product. Product is this, right? So its reciprocal will be what? 1 over this. So that is 1 over 20, right? So 1 over 20 is this. So we can say that option C is correct in this case.